Hello, everyone. Good morning. First of all, thank you for attending Sbgames 2021. And today we are going to start the computer session number 5. It's about software engineer and HCI. And for this session, we have 5 papers. And I would like to tell you to put your comments in the YouTube chat or Discord that at the end of the presentation, we will forward to the author. And also feel free to put it in English or in Portuguese, it's no problem. And you want to begin the presentation, let's start with the paper. Let me see here. The paper is Utopic Sense, a tool to support the use of synesthesia as an assistive resource in 2D games, with Adriel Augusto e Fábio Coutinho, do Centro Federal de Educação Tecnológica de Minas Gerais. Welcome, Adriel.
Hello, good morning. I'm Adriel, and I'm here to present to you Utopic Sense, a tool to support the use of synesthesia as an assistive resource in 2D games. Starting with the concept of synesthesia, it refers to a situation in which sensations of stimulus are perceived through different senses. For example, there are some people with neurological conditions where they can sense visual effects simultaneously when they hear a sound. In our context here, we are going to use more the algorithmic synesthesia concept, which comprises multimedia processes in which sounds, images, and haptic sensations have as generators the same computational process or data source. For example, when you are playing a game and you hear a sound and simultaneously you feel the vibration of your controller, you feel simultaneously more than one sensation. Regarding the concept, we observed some problems. We observed that accessibility in games is not always prioritized as it should, of course, because there is a financial and time cost for the synesthesia implementation. And we observed also that there are not so many options to help indie developers to implement synesthesia. So we took as motivation that many games already use visual and haptic alternatives to sounds. For example, Mark of the Ninja, which uses visual effects associated with sound effects. And seeing these games, we wanted to automate the process of inserting visual alternatives for sounds in games to help with the problems we mentioned before, and also to better accessibility into the games for deaf and hard of hearing players. Our solution would be a software to facilitate the synesthesia implementation, Utopic Sense. The tool was implemented within Unity game engine, and we chose Unity because it can be used to 2D, 3D games, and it's used by many creators, developers to reach a broad audience, a broad public, and it could reach a lot of people. To develop the application, we did some requirements gathering, which consisted in we took 11 games, we played them without any audio, we used a lot of empathy here, and we evaluated many situations that were not good for accessibility into the games. And I'm going to exemplify a few, but it happened in many games that we evaluated. First of all, we found many situations that sound is used to hint some off-screen event that is going to happen, and if you don't hear the hint, it could be frustrating sometimes. For example, in Sonic the Hedgehog 2, you see the situation where a projectile comes up after a sound hint, and if you don't hear the sound, it could be frustrating. Another situation that we saw a lot is, for example, in Rayman Origins, but it happens on other games as well, is that sound is used a lot as hint to secret levels that you can score to unlock new levels. So if you don't hear the hints, you are in a little bit of disadvantage in this aspect as well. So it's a point of weakness on accessibility into the games. Basing on that, we did the requirements list. The most important things here is that we wanted to generate a software that could generate 2D visual effects based on sounds for different game genres and to support appliance of visual effects from different artistic visions. And after that, we went to the tools implementation itself, Utopic Sense. Our mapping consisted in volume to opacity, frequency to color, and sound rich to visual effect rich, which I'm going to illustrate to you now. For example, here, the volume mapped to opacity and the frequency mapped to color. And the sound range, it's compatible with the sound, the effect range is compatible to the sound range, as we see here in this image. And as for frequency mapping, we discretized the sound in 512 samples. We did this empirically. We used powers of 2, but in this case, we chose the value because it didn't impact too much on performance. And we used a fast Fourier transform to map the sound effect to the frequency ranges, which shows this calculation, even though it's a complex calculation, but it didn't impact on our performance and offered more accurate calculations. And we mapped the color to the default mapping was based on the light spectrum. As for the interface, we have 2 modes, the standard and the simplified mode. The standard mode is the one we map frequency to the colors, but the users can choose any color they judge fit for the project. And in the simplified mode, there's no frequency mapping, just one color gradient. Here is another part of the software which the user can choose textures, any texture to apply to different sound effects as they see fit. So this is to better artistic views to use it there. We have also the functionality to change the effect emission speed, as is illustrated here. It goes from low to extreme. And we also have the functionality of shaders. The user can use the fold, multiply, and additive shader. And here we have a small video of me applying the effect on scene. You probably won't be able to hear the sound, but in the case there is an object there here with a sound attached to it. And when we run the game, I'm going to show that there is a sound that comes from there, but you don't know if you can't hear the sound. And then I choose to, for example, apply effect number 1, which comprises the first image with a median effect speed. And then the visual effect works in the scene. That's an example. It's very easy to apply. And we did it to facilitate this kind of implementation into the games. Then we went to evaluation, which consisted more of a pre-evaluation, and we got some results based on that. The Unity projects, we did a first evaluation with checking robustness of the tool in different game projects. We selected 5 Unity projects to use, Utopic Sense, different projects like 2D projects, and as illustrated below, and then we used them, the observations we did, to make the tool better before the next step. And after that, we did a preliminary evaluation, which consisted in an assessment with 4 Unity users in a semi-controlled environment. And these users, they performed 17 tasks using the Utopic Sense software. The users were programmers, Unity programmers, and 1 designer. And we apply a post-test questionnaire so that we could gather feedback and points to get better our application. And we noticed that people really liked using it in general terms because of the simplicity. And that was pretty much the conclusion. There were some things that weren't too much opened for them because there are some functionalities that are used on our interface but are integrated with other Unity functionalities. As for the conclusion, we want to talk about a little bit of the contributions. Now we present a tool to facilitate the use of the algorithms in the stage process in games, specifically for sound to image effects, and we propose to reflect about problems that can compromise accessibility of deaf and hard of hearing people into the games. And the most important contribution is that in this field has a lot to grow. There is already work on process, but it's nice to have a more contribution in terms of software, so we can help people to research a little bit more on the matter. And as for future work, we want to facilitate the implementation of haptic sensations that control vibration in the software, and test and expand the particle systems to better fit 3D games. It already works for 3D games, but we didn't test it thoroughly, so we could really consider it in a serious way for 3D games. It's the first version for 2D games, but for future work, we want for 3D games as well. Some references, and thank you. Do you have any questions?
Thanks, Adriel, for the nice presentation. Let me see if you have questions here in the YouTube. Luis Chamovitz has a question for you, Adriel. It asks, first, congratulations for the nice work. And the question is, did you evaluate the tool with games to see their impression?
With gamers to see their impression? Yeah. Not yet. We want to do it. Actually, we didn't have enough time regarding it, but we want to do this testing with specific games and specific gamers as well. And we wanted to test it with deaf and hard of hearing players as well as future work. But yeah, we consider it, and we are going to do this as future work as well.
Okay, thank you. There is another question from the Travares. He says that, in his opinion, synesthesia is a cultural perception. The smell of a certain fruit, for me, can be a positive feeling, while for another person, for example, it can be a trigger. The question is how to handle this in your tool.
Well, actually, we already did. We implemented an option in the tool where the user or the developers, they can offer the option to deactivate the visual effects if they want to, because we know this is an alternative, but it's not for everyone, as you said, and that's why we want to integrate it with different synesthesia effects as well, because we know that some people might want to just have an haptic effect, the control of vibration, they don't like the visual effects, for example. That's why we propose this as future work. And we also treated that, the triggers and problems, in a help section that there is in the application, that we write some observations so that the users, the game developers, can have this consciousness, this awareness about the subject when they use this on their games.
That's nice. Thanks a lot, Adriel, for your words, and congratulations for the presentation.
Thank you very much.
Next, move on to the next paper. The next paper is the Genebook, a game engine to provide. Yeah, that's right. The next paper is Genebook, a game engine to provide electronic game book for adventure games, from Victor Travassos, from the Universidade Estadual de Feira de Santana. Welcome, Victor.
I think a video will show, the organization will show the video now. Or I will
Hello everyone, my name is Victor Sarinho and I will present our work, Genie Book, a game engine to provide electronic game books for adventure games. Digital books have begun in notorious space in today's internet time, and it's a consequence of the benefits to use them, such as no trees required to manufacture them, no space to store them, and so on. Per game books, it's a kind of book with a story that can be read sequentially or not, where the player keeps reading until he reaches a fork in the story, going to a different page every time the book asks him to make a choice. Game books became famous in the past and a possible resurgence of game books coming, and it's a consequence of the combination of readers' interest with presentation novelty currently provided by the technological support of ebooks. However, despite the multimedia resources offered by ebooks, due to security reasons, they require a static structure for navigation and presentation of the elements, and for portability reasons, not all book elements can be displayed correctly in all ebook readers. In this sense, there is a difficulty to dynamically represent in a systematic reusable way all the necessary elements to create game books. And this problem can be perceived when we analyze the current production strategies of games and text adventure games, where the developer only desires to set and include game characteristics without worrying about interpretation and execution details behind them. The objective of this work is to present the design, production and validation of Genie Book, which is a game engine proposal to provide electronic game books for adventure games. Genie Book is composed by three main elements: a game data model, a multimedia game panel, and a game book builder application. And the idea is to use Genie Book to construct ebook packages in a kind of G-book in line with security limitations defined by ebook readers. As related work to provide gamified ebooks, Okuda and Emi tried to provide a kind of EPUB-free game based on HTML interactive functions. Figueiredo and Bidar provided a Unity base to provide a novel interactive book, which he called the G-book. And next, together to Natalio, it provided EPUB-free and iBooks author versions of this kind of book in an educational game perspective. Drotsas et al. Provided interactive and personalized e-books for educational purposes. Miller and Rannon provided an open-source electronic textbook that incorporates a number of active components. And Sigartian et al. Provide a kind of a hybrid e-textbook to allow the interaction between digital and physical world. Regarding the Genie book construction, it was performed in three main steps: the creation of a JSON model able to represent text adventure games, the production of a game panel with an embedded game cycle able to execute the modality JSON, and the implementation of a game book builder able to put the game engine together with the JSON data in a valid EPUB file for ebook readers. For the JSON game data, 5 main features were defined: players, actors, items, locations, and ends. They are based on constructors represented by related text adventure game engines such as Text Adventures, Text Engine, and Adventure. And they are completed by features able to control game flow for game items, actions, hashes, and ends such as requires to show, requires to perform, and requires to finish. Some extra structures were also defined to represent game messages such as game title, game introductions, go button, and credit texts. Together, they define 6 main features that compose a feature model based on 86 features to represent game books for text adventure games. For the game panel, 11 predefined areas were provided to organize the game book, such as introduction, items, actions, options, and so on. They are composed by some HTML elements, whose tags can be manipulated by inner HTML and style properties, together with some required media that was previously included as HTML tags for media content but with the hidden property activated. Finally, a pool of static buttons for possible items, actions, and exits are available to the player according to the gameplay. Predefined areas can be shown according to the current game state of the book. For example, when the game status state is activated, Some predefined areas such as items, actions, and exits are shown to the player. They describe the current items in a location and the possible actions that a player can do according to the game stats. When a player presses an action button, the game info state is activated, showing the result of the action execution that perform an update of the game context as a whole. Finally, if a game end condition is satisfied by the current game status, the game end state is activated, showing the end of the game as a result. For the game builder, two JSON files are used to prepare and build a final and valid debug file. The book config defines the necessary information to prepare the game book according to the EPUB format. The game config defines the game logic of the game book according to the proposed DSL based on features for text adventure games. By using these two files, some steps are necessary for the game builder to provide a valid EPUB directory and content. Most of them are related to open, read, copy, and move content to the final directory of the game. Others are necessary to integrate the game engine and the game config data, prepare the engine file for the game panel, and prepare the package OPF file with references for the static media resource. After complete the game builder, together with the game panel and the JSON model for text adventure games, an evaluation gamebook calibration was developed using the proposed gamebook assets. The game objective is to escape from a thief that invaded the house, where a battle against the thief is performed where the player can win or not according to the player luck. This partial description of game config file shows the game logic about the attack thief and verified thief resistance actions. The requires to show verifies if the attack the thief action can be shown to the player or not. The requires to perform reduce the thief's life in a random value and calls the verified thief resistance action. And the verified thief resistance actions verify if the thief is alive, and if he is alive, he will attack the player and reduce his life. Regarding the gamebook execution, the left picture shows the initial image of the invasion game. Here it's possible to see the Start Game button that, when pressed, activates the game status, hiding the introductory game info and showing the story, items, actions, exits, and options areas with the respective player location content. Game inventory, game map, and game info states are also activated according to the respective button click. And when one of the ends condition is satisfied, the game end state is activated, showing the final results of the gameplay. As obtained results, Table 1 presents the used ebook readers and the respective platforms, together with identified inconsistencies and possible reasons and solutions to solve them. In this sense, only desktop and web versions present some image dimensions and audio problems, and only one web reader presents some security problems to execute the provided gamebook. Regarding the reuse metrics obtained with the JavaScript files of the Invasion gamebook, a total of 77% of S-Lock reuse and more than 93% of cyclomatic complex reuse were obtained for them. As conclusions of this work, a game engine proposal able to provide electronic gamebooks was presented with success. By its use, new gamebooks for each new JSON data without worrying about interpretation and execution details of ebook readers can be provided. In this sense, Genebook can provide valid gamebooks according to the EPUB format in a systematic and reusable perspective, showing interesting reusing metrics results and possible extensions for different game environments and platforms. As future work, it's necessary to make Genebook available for the community, applying courses to publicize the tool and get feedback from external developers. It is also important to convert available gamebooks to the EPUB format by Genebook assets for validation purposes. Consider the Genebook evolution, a new version with FPS generation and graphic manipulation is in course. And it is also necessary to make a kind of graphic editor for composed game adventures according to the proposed JSON model. Here are the references of the presentation, and thanks for watching.
Thanks, Vitor, for this nice presentation. And it's an interesting approach for adventure games. Right now, we have a question here from Vinicius. He asks, are there any game book already available to be tested as a result of your work?
Well, actually, only the invasion game was developed, but we are trying to. I am making now a new Genie book, a second version, because we found some problems with this pure construction of EPUB files, in special when rendering the content, the text and images. We have some changes that you don't like it. We want to make something very very correct. That's the point. And the Canvas HTML property, for example, present better results. So we are now interested in provide this new version instead of making new game books or getting as a published old game book and convert to the EPUB format. So our objective now is to make this new version of the book, and next we will provide more game books and other kinds of games inside this approach, using this approach.
That's very nice, Vitor. One of the area that I see your approach being used a lot is for education, for example.
Yes.
By teaching creative stories related to a lesson topics,
Yes.
for example. How easy do you think it's for them to use Genbook to make an adventure game based on a topic theme for their lesson?
Well, it's more simple than using the JavaScript engines that we use as reference, for example, because we simplified them in a only kind of JSON and 6 main features to configure them. Only the evolve property of the JavaScript, we can introduce some kind of programming approach that can be replacing the filter with a graphical interface, for example, something like Scratch, to make the logic and operational relations and something like that, maths. So we can apply a kind of graphical interface and allow this to professors and educational professionals to use the tool without a problem. But our main objective is to make something simple to share the game. So with an EPUB file, we can send for on WhatsApp, on a group of professors. Imagine something like that. Our main objective is that. So is the distribution. Next, we'll make something more easy to develop games using it.
Yeah, it will be very, very good for the teacher to use such a tool. Also, we have a question here. Geraldo would like to know if this is widely available. Maybe he can try it. It's available for you can download your tool for use, for example.
I don't share it. That's the point. We are providing the new version. The new version we will share for everyone. I think that two more weeks we can finish the new version. Yeah, we now have some interesting results with drag and drop and camera 2D inside an ebook file. So we have some very nice results, and we'll share. I think in the end of the year we will share it for everyone.
Okay, people are going to get your tool to use later. Also, we have another question here from Flavio. Did you use some extended version of JSON?
No, the
No.
standard JSON. Only the JSON, we have an introduction of the evolve. The property with a kind of code will be interpreted by the evolve function of the JavaScript. So it's the only restriction that we need to program at some point. Yes, we need this point. We need to program the game logic. That's I think it's a problem. But in the future, maybe we can replace it of a graphical structure or something that can connect a kind of interpreter, for example, and eliminate these characteristics of the JavaScript that we are using. I don't like it, but it's necessary at this moment.
Yeah. Finally, our last question is from Geraldo. He's asking if you plan using this tool for educational application software engineer. It's the same, maybe the same question you have already told.
Yes. I'm trying to develop some kind of games to teach software engineers. I have a plan to next year to provide 5 kind of games. One of them was published just last year, and we will convert them. We will include them and share them as EPUB files. Maybe in the SBC list, if you receive, oh, this is our book with a game inside. So I'm saying for you guys, okay? It's me. So please try it and complete our Google Forms to evaluation and publish the work with success, okay?
Okay, very nice, Victor. Thanks a lot for your presentation. Congratulations.
Thanks.
Let's move on to the next paper here. It's the paper Real Shooting, Expanding the Experience of Point-and-Click Target Shooting Games from Emerson, Creto, Joaquim, Cavalcante Neto, Antônio, Jorge e Ícaro, da Universidade Federal do Ceará.
Real Shooting, Expanding the Experience of Point-and-Click Target Shooting Games.
Hi everyone. Being direct and precise. We proposes a solution to achieve a new interaction with regular point-and-click shooting games. For that, we developed an intermediate solution that can adapt gameplay with no need to modify the original games. But for a better understanding, we will contextualize and explain all the work and motivations.
Introduction.
Shooting games underwent several transformations throughout their long history. Let's show a timeline with some points of this transformation and evolution. Target shooting games have a long history since they appeared in tents in the famous carnivals of the 1890s. Later, with the evolution of technology, it was possible to substitute the physical projectiles by short emissions of light beams. So, light guns appeared as simulacra of real weapons. The evolution continued with the shooting systems and capture sensors, to the point of allowing human and machine competition as in Jungle Charlie, from 1971. In 1972, the Magnavox Odyssey became the first domestic game console to have a light gun. In the 1990s, adopting CCD sensors made it possible to use video cameras with smaller dimensions and lower costs to capture the light beams fired by the simulacra. And with that, new specific genres of games have emerged, such as target shooters, which feature moving targets on static screens, and rail shooters. Despite the technological advances, the participation of shooting games in the market suffered a significant decrease mainly because of the launch of titles with questionable quality and the consequent public's lack of interest. In general, replicating the technologies used in the most advanced games, which employ light guns or similar devices, demands high costs, incompatible with domestic environments. In this article, we propose a low-cost solution that makes it possible to use weapon simulacra or real weapons, in standard shooting games, with no need to adapt those games. For this purpose, intermediate hardware and software elements are proposed, presenting new interaction possibilities to the players.
Solution.
The traditional interaction model is this, where a player uses a traditional interface, mouse, gamepad, and touch screen, to interact with the game. The proposed solution is this. It defines a set of intermediate entities that allow the player to interact in a new way with common shooting games without requiring any changes to be made to those games. Thus, instead of using a computer mouse, the player uses a simulacrum with a laser emitter attached to its barrel. When the trigger of the simulacrum is activated, the emitter shoots a pulse of light to a screen. Then, specific hardware and software elements detect and identify the point where the laser pulse hits the screen and automatically perform the respective command in the game, simulating the mouse click in the appropriate game region reached by the virtual shot. Adopting the proposed solution, we change that traditional pipeline, so that the medium of interaction becomes a weapon, real or simulacrum. Therefore, To intermediate the player's interaction with the game, we include the following entities: an emitter, a video output device, a capturer, and a calibrator. And now, we will expand and describe the architectures of the entities of the proposed solution.
Emitter.
The emitter, which is the intermediate hardware element between the player's weapon and the game, detects the sound generated by firing the weapon and instantly shoots a laser pulse. In general, the emitter works as follows: 1. The player fires the weapon by pulling the trigger. 2. The weapon's precursor or similar mechanism emits vibration or sound. 3. The physical stimulus, vibration or sound, activates an internal sensor on the emitter, accelerometer or microphone, for example, and 4. The emitter shoots a laser pulse.
Video output device.
In general, the video output device is the hardware that displays the images seen by the player. It can be a screen projector, a television, or any other device with the same purpose.
Capturer.
The capturer, which is placed in front of the video output device's screen, is a video camera that detects the reflection of a laser pulse fired by the emitter on the screen. In general, the capturer works as follows: 1. It monitors the image produced by the video output device. 2. When it detects a laser pulse on the screen, it saves the respective video sequence. 3. The video sequence is divided into individual frames. And 4. The capturer makes those individual frames available to the calibrator.
Calibrator.
The calibrator, which is the software entity responsible for ensuring the interaction of the game, processes, in real time, the frames saved by the capturer, using computer vision algorithms. Such processing aims to identify the exact location of the screen reached by the emitter's laser pulse. So, the calibrator maps the physical screen point to the individual game pixel. The calibrator performs, only once, the homography, which is the processing that compensates for the deformation resulting from the misalignment between the video camera's plane and the game's projection plane, and calculates a threshold that is based on the ambient light of the room. Considering the homography procedure and the thresholds calculation, the calibrator works as follows: 1. After receiving frames from the capturer, the calibration controller sends them to the image processor. 2. The image processor converts the image to grayscale. 3. The calibrator divides the captured image into regions according to the threshold and based on comparisons of the gray levels of the pixels. This process separates the corresponding pixels from the laser pulse. 4. The calibrator identifies all the pixels corresponding to the laser pulse, calculates the center of those pixels, and stores its Cartesian coordinates in the position vector. 5. The position vector sends the ordered Cartesian coordinates to the calibration controller. 6. Considering the homographic matrix previously generated, the calibration controller converts the center of the laser pulse from projection coordinates to the corresponding game coordinates. And 7. The coordinate controller sends the coordinates to the mouse controller in order to position the cursor on the respective game position, and to perform a mouse click, an interactivity action with the game.
Implementation.
To validate the proposed reference model, we implemented a version of each architectural entity. Regarding the hardware, we use these devices that represent each of the entities in the architecture. For the software part, the implementation of the calibrator used the Qt multi-platform framework and codes in the C++ programming language. We performed experiments with 4 different games to test the use of the implemented system. The games used and tested with the proposed solution followed 2 strands. The first being composed of 2 prototypes that we developed specifically to test the solution and 2 other existing and commercially published third-party games.
Experiment.
After implementing the solution, we run an experiment. The environment used for the experiments is a room located in the basement of a business incubator in the city of Évora, Portugal. The room has the dimensions shown in figure. To carry out the experiments, we used a wide variety of weapons in different categories. To complement the experiments, we invited guests and members from our development team to test the solution. Each participant chose a weapon and played all the 4 games described before for approximately 1 hour. Afterward, they reported their experiences.
Results.
Considering the use of the proposed solution, we obtained the following results. The level of laser recognition by the calibrator approached 100%. The processing time to perform the input interaction varied between 13 and 21 milliseconds. Some input lags between a mouse click performed in the game and its respective reproduction on the projection screen were observed, but, in our case, the participants did not report that problem. Participants reported muscle fatigue due to the weight of the weapons but understood it as part of the experience and immersion. And they reported observations indicate that our solution was feasible and provided an exciting way of interacting with some games.
Conclusion.
This paper proposed a solution for capturing laser beams and allowing players to interact with shooting games without any adaptation of the games. We implemented the proposed solution and tested it. The obtained results indicate the solution and its implementation are efficient and represent a different approach that works for both legacy and new games. We intend to apply tests with more participants of various profiles considering different assessments such as system usability and player engagement. So, we hope our solution can bring new interaction alternatives for different purposes, from reviving old games, which were forgotten due to the fall in the arcade market, to new genres of games, such as point-and-click games.
Thanks for the presentation, Icaro. It was a very innovative presentation. I liked it very much. Let's see if you have a question here in the YouTube or Discord. I have one question for you, Icaro. When we work with image processing, normally the environment, the light in the environment has influence in the processing. Do you have, in your approach, it's a problem for for capturing the sense of the lens of the target?
In
Do you-
our approach, we don't have any problem because we have an algorithm to make a threshold, and in this we can identify better the spot of light. But we have a problem only when the light in ambient is much greater than the light of ray, the ray of the spot.
Okay. Let's see if you have questions. At the end of your presentation, when you demonstrate a person playing the game, I could see some mouse input latency, and you also told it in your video, in your presentation. Maybe do you think there is another approach for solving this problem?
Can you repeat? I don't understand.
Yeah, at the end of your presentation, I could see a person playing the game, and as he plays, as he moves the gun, the mouse, the point of the mouse in the screen was not following in real time, let's say. So there was input latency in the movement of the gun in relation to what was presented in the screen. Do you have some ways for improving this latency in the mouse?
Yeah, there are, but when we made the interview, we saw that the persons didn't identify any delay in the response of the game. Then yeah, they didn't identify any delay.
Okay, we have another question here from Geraldo. Did you try with games with red color?
No, no. We only try it with these 4 games.
Okay, thanks a lot, Igor, for your presentation, and congratulations for your work. Let's move on to the next paper. It's Game by End Users, Analyzing Development Environment, from Joana e Raquel, da Universidade Federal de Minas Gerais. Welcome, Joana.
Hello, thank you. Can I start? Okay, so hi, my name is Joana Gabriela. I'm going to present the article Game by End Users, Analyzing Development Environments. This work was developed by me and my advisor Raquel Oliveira Prats, and we are from the Department of Computer Science of the UFMG. So a little introduction. Digital games are quite popular and are growing year after year. But nowadays, in addition to playing games, many users want to develop their own games and share them. However, game development is considered challenging, especially for end users that are people who have no programming experience. Recently, tools have emerged to support these end users in creating their own games without the need to know programming language. Because of this, it's important to understand how the game engines help end users to construct their own games. In this work, our goal is to better understand this initiative and answer the following question. What strategies and constructs do game engines use to allow users with no previous knowledge of programming to create games? Or methodology. So, to select the games, we considered those that were free and did not require coding. We also took into consideration the 14 criteria recommended in Covan and Capralos. As a result, we selected Stencil and GDevelop. We used the semiotic inspection method or SIM, that is a qualitative interpretative method for evaluating the communicability of interactive systems based on a semiotic engineering, a human-computer interaction theory which perceives the interface of a system as an indirect one-way communication from the system's design to users. SIM allows for a systematic analysis of what designers have encoded in the systems as the solution being offered to users to achieve their goals. So SIM was independently applied to each system. Next, we triangulated the results obtained for each systems, identifying aspects that were considered relevant by both designers to allow end users to create games. Then we obtain our set of 7 constructs that are primary game elements available to end users to create a game, and 6 strategies that are the support offered by end user environment to support general development activities. Next, I will briefly present these results. So first, the constructs. The first is scenes and can be defined as the environment in which the game takes place. For example, a world or a level. We have here in the geometric monster is the GDevelop interface, and in the bottom is the stencil interface. So game elements. So game elements are basic elements that can be added to a game scene, such as characters and text within the scene. A group can be seen as an element that groups several other elements that will be treated as a single object under some user-defined aspect. Events. So events can be seen as occurrences that take place in the game that can trigger any action or feedback in elements or scenes. So they are used to introduce logic into games. Events convey the idea of cause and effect, something usually clearly understood by end users, which facilitate the use of this metaphor. And in both platforms, an event is associated with a specific scene. So we have the behaviors, and behaviors add meaningful functionality to objects, scenes, and actors, for example. So Features such as allowing the player to move a character with the arrow keys is an example. So once the user defines a behavior, it is available for reuse by other elements of the game. Collisions. The concept of collision represents the definition of action that should take place when two game elements like objects, actors, characters collide. Physics, so the use of elements related to physics like force and gravity is something commonly used in games, and the tools are also provide the support to users, allowing them to define the presence or not of gravity, the direction of force, speed, and others. So now we'll present the strategies. And the first one is adopting a familiar interacting style. So both engines adopt a drag and drop interacting style. Users can use drag and drop technique in both the logic and design part of the game engine. Defining inherent modularity. So the game engines organize the games in constructs that compose a whole. Providing extensive help. So the tools provide easy access to documentation, forums, tutorials, and social media. Help elements are always clearly available in the interfaces, either via tooltips or help systems. Facilitating testing and debugging. So both systems allow games to be tested at any time using a single click. Exporting games. So the tools allow games to be exported easily by selecting the format and then exporting, which takes one or just a few clicks. And supporting advanced users. So both systems include the possibility of their use by more advanced users or even professionals, by offering users the possibility to use a script language in the process of creating a game. And a little discussion. So our constructs and the strategies allowed us to compare and discuss the difference in the solution presented by each system. The develop creates a more abstract level over the programming concepts and presents to users most of the discussions on game logic as a cause and consequence definition, with the possibility to include conditions to events, for example. So beginners can do so through configurable menu options. Users with experience in scripting language can also use JavaScript in their game creation process if they would like to. And they have a multi-language platform, and it's interesting. Stencil addresses more directly the concepts of programming, such as logic and the use of resource in their user interface. They offer block programming to users to create their games that allow for greater freedom, but is more complex than configurable menu. The scripting language HAX is available in the dashboard and is easy to see that the code created through the block programming will be C in X, which may encourage users to create familiarity with it or even learn it. And Stencils inspires the reuse of game elements, allowing the reuse of actors in several scenes and accessing the game elements in the repository called Stencilpedia. So, conclusion and future works. First, the set of constructs and strategies identified are an original contribution that is relevant to people interested in research, development, and even adoption of game engines, aimed at supporting end-user development of games. So researchers can use this set of constructs and strategies to investigate requirements for end-user game-oriented visual languages and end-user development environments, as well as to guide, to evaluate or contrast them. For professionals interested in developing new end-users programming engines, the constructs and strategies can help them to make decisions regarding the system they intend to propose and develop. Whereas the constructs are specific to game domain, the strategies are focused on supporting the end-user development in general, so it can be applied to other domains. As we have discussed, the systematic analysis of each system allow us to identify their distinctions and the benefits offered by each solution and contrast them. About the limitations and future works. the limitations. Only one researcher conducted the complete analysis of the systems, but this limitation was minimized by presenting and discussing the results with a second researcher about the number of systems analyzed. This is in the qualitative research, so only 2 systems were analyzed. And the future works would be interesting as a future work step to analyze other end users' development game engines to future consolidate our results, as well as to investigate if other constructs and strategies can emerge, and also considering the constructs and strategies to build new systems. And thank you for watching. And it's this.
Thanks, Joanna, for the presentation. Let me see if you have questions in the YouTube or Discord. We have a question here from Flavio. Hi, Joanna. How did SIM aid in determining strategies used by inspected software? Did you use the meta message reconstruction or something else?
Yes. Because of the time, I couldn't explain about the process of applying the SIM. So we applied the SIM using a scientific way application. So we applied in one and after in the other. So we analyzed the meta messages generated by H1, and using this, we could perceive what are the constructs and strategies used in each systems. And of course, it's different the way that each systems treat this constructs. For example, in G development, they use the metaphor of objects. So everything that you can include in the game is an object, even if it's a video or a character or something like that, a text. But in Stencil, these game elements that we call game elements, they call as resources. So they have just 5 types of resources. They have the scenes, is called a resource, and actors and fonts, sounds, backgrounds. So they are different ways to do the same thing. So we analyze this. It is more clear when we can read the article, because there we could explain each one, how it appeared in each one. So, but we did it analyzing the meta message of each one.
Okay, thanks, Joanna. I have a question also. Is there a reason for you to choose these 2 tools for analyzing?
Yes. At first, because we do a research in thinking about how to create games without coding. So at first, the first stage for selecting the game engines, we did a research in the internet using sites with rankings, rankings of game engines, and using this, we create a set of game engines, and then we applied the criteria selection for what fits better to our intentions.
Okay, maybe one path for you to also argument your arguments is to choose some participants and ask them to create a game, use these 2 tools, and perform some analysis if they can conclude the game. Or do you think perform such kind of experiments?
We don't. In this work, we just did analysis using the things. So it's a inspection method. So it's not a method that users use to analyze. But another thing that we use to select this game engine is to solve about the community. So both are a active community. So they have forums and another social media that they have games being created using it. I think in the Sbgames we have a game called Vai Juliette, and it was created using the GDevelop, for example. So it's the both game engines are used, but we don't in this project we don't use users to say what they think, think that what more difficult or more easy. It's just inspection. We just apply the inspection method.
Of the tool, okay. We have a question from Esteban. How was the experience and profile of the user?
I don't know if I understand exactly the question. Repeat, please.
Yeah, how was the experience and profile of the user? But from what I understand, you didn't perform any kind of analysis of the user, right?
Yes, we analyze using the scene. For example, we have a series of steps. So the users, the profile, as we can say, the profile of the user that we consider is a teenager, because both platforms they have this idea that teenagers and adults can use. So we consider a teenager in our analysis, a teenager that is trying to create their first game. So we choose two games in both platforms using the same idea. For example, in the development, we create a game called Geometry Monster. So some shapes like circles and things like that falls, and we have this monster, and he needs to catch the shapes and avoid the bumps, for example. So the user needs to control the monster just moving right and left. And in Stencil, we create a game that we have some ships, enemy ships on the top, and in the bottom we have our ship, and we control the ship to go left and right too, and it can shoot and destroy the ships. But the idea is using this movement, and we need to do anything like that. So we create games, we can kind of same context, and thinking about a teenager with was using this game this game engines for the first time. This was our scenario to analyze. I don't know if this is the question exactly.
Yeah, I think it is. I would like to thank you, Joanna, for your presentation, and also Raquel, that is putting some comments in the chat too. Congratulations for your work.
Oh, you're welcome.
Let's move on to the next, to the last paper from this session, which is Decree DSML for creating educational analog card games, from Rubens Anderson and Rosana Andrade from the Universidade Federal do Ceará.
Morning. Today I'm here to present to you the Decree DSML for creating educational analog card games. My name is Ruben Silva, and the second author is Rosana Andrade. This is Sbgames from 1221, and yeah, let's go. Here are the summary of this work, and first I will introduce you to the motivation. We have MDA, which is model-driven engineering, and MDA is one way to promote an effective system development approach through software frameworks and meta-model structures. The main factor of this method is the creation of models. In MDA, we create model of games, not the game itself. So if I want to create the game, I will have to manipulate the model and then translate it to the final code, which can be analog or digital game. This model bases the development of the real systems. They aid the process of concept, build, and prototype in a standardized and semi-automated way. However, these models define specific software to specific domain problems. So if my problem is a little bit outside the domain of the DSML, the model generated can be not so effective or effective at all. So how do we use this approach to develop games? In our research, many MDA approaches create game meta models in many domains as educational games inside many knowledge fields. Some of them create only the UML models. Some others create the full game from the model, aid with the translation software called model to artifact. However, all the domains found reside only on digital games. None of them focus on analog or hybrid games. So with this work proposes an MDA approach to develop analog educational card games, called the Create Card Games. So here I have some statements of this research. The motivation is the lack of the DSML approaches for educational analog games itself. The research question is how to create an educational analog card game grounded on game design approach aided by the software engineering. With this, the expected contributions is to provide an approach to generalize educational analog card games for non-experts on game design with personalized educational content. And also, we expect to promote the discussion about the MDA approach for analog games. Talking a bit more about the target audience, the computer science professors whose subject contents can be translated into unitary questions and answers, so that each question has one or a set of defined answers, and the teacher has the role of developing the game. So the mechanics and dynamics in accordance with the educational objectives. However, the teacher does not need to have expertise in games to do this. All you need to do is follow the step-by-step instructions and use the software tool to implement the game. The gameplay will have the quiz as the most basic game mechanic, which is the questions and answers described by the teacher. However, other main and secondary mechanics can be part of the repertoire, such as trading, deck, take-that, card drafting, RPG, and many others. So here are present the method for developing the DSML. The domain phase consists on two types of development, which is top-down and bottom-up. The top-down we search for generalizations of educational games, and the bottom-up we search for analog games, and this joint generated the domain of this DSML. With the domain defined, we developed the target model, the abstract syntax, and the static semantics. With this, we defined the model to artifacts conversion, and then we evaluated it. So here are the domain and abstract syntax. Use class diagram to represent the abstract syntax. So here we have all the classes that defines the domain of the educational analog card games. So to ease the process for non-experts, we designed a model template in UML for a simple game loop, and this model can be extended to another game from the perspective of the professor. With this, the user can manipulate and generate the personalized rules, cards, info, and also understand better the way to generate the game itself, according with own context, avoiding the need to start from scratch. This code is in JSON, which is a simple to manipulate text data structure. And as a future work, we want to develop a software web interface to facilitate the process of modeling, creating, and download the game itself. So it will be not necessary to manipulate the code of the game, but only the interface. So here we have the template game loop. As you can see, we have some rectangles, which are the states of the game. And each rectangle has some arrows. There are the rules of each state. So each state has a purpose, has a meaning. So it encapsulates all the rules for that meaning. As an example, here we have play a challenge, which have all the rules for playing a challenge. Also, we have some special diamond shaped state. which is attached to a regular state. And this diamond means a condition to go to a state or to another state. And this choice depends on the game context and the moment of the game while playing. So the loop goes on from play or next player, and the game is over if the game ending condition is satisfied. So here we're going to talk about the evaluation. We want to test the suitability of this approach. The evaluation of this DSML aims to show whether the tool is suitable. For this, a version of the educational game Grid Test card game was developed. The Grid Test is an educational analog card game that aims to practice the study of software testing. The gameplay consists in identifying the type of software test that was used on the given scenario. So it will act as the challenge of the game. And if the player can catch bugs with the game cards, he or she wins a point. This game was chosen due to its different types of game mechanics as negotiation, bonus, and since those types of gameplay were not included on the basic model of the career. So here we have the game, the Greater's card game loop. It's very similar to the template. However, we have a third loop, which is negotiate with players, where we define the negotiation rules for the game. And if the negotiations are well or not, they go to play the next player, the player can choose to play challenge, play bonus, or next player. So here I have the code from the demo, and by now it's only for testing in Angular. So it is necessary to compile the projects and run it from the local host. But basically we have here the game model and all the information from the game. So if we manipulate this and we go to the browser, so here in the browser we have the web page on the local host. So if we run this demo and see the game, we can check here the manual of the game, the game info, the deck explanation, and the game rules that was generated from that UML diagram. So if we want to print the game, we can check here that it was generated separately, the cards and the game manual. So the game manual has all that info, so as the cards from the deck. So now we have the final remarks. This work presents the DCREA, a domain-specific modeling language to aid the development of analog educational card games. Is the SML a suitable approach to generate analog games? Well, I think we cannot answer this with 100% sure, because it's necessary to show much more evidence that prove or disprove the efficacy or the efficiency of this type of method for this problem. However, with this work, it was possible to implement a published educational analog card game and even improve it with relative easily. Also, it's possible to implement a whole variety of games, since the model of the game loop can easily be extended to any type of rule and therefore to other analog mechanics. Although it's necessary to improve the evaluation, this is an initial step towards the direction of MDA for analog games. And as future work, we will evaluate the DSML with professors, students, and game designers in order to improve the correctness and completeness in providing a useful tool. Furthermore, we will implement a web SaaS application based on the DSML to ease the process of modeling and downloading of the games. Here are some references, and thank you.
Thanks, Rubens, for the nice presentation. It's a very interesting approach for educational game. Let's see if you have questions in the chat or in the Discord. I have a question for you.
Okay.
Right now, how your what how your what's your opinion for how easy for professor, for example, to use your approach?
I think it's a little bit difficult because I think it's not the ideal because you have to deal with JSON code yet. So it's necessary to change the information manually inside the code and just reload the projects to see the results on the page. However, we are developing a web system, a web interface that we work with this problem to fix this, and in order to ease the process of creating the game.
Oh, that's very nice. And was there a specific reason for you to use a card game, or it was?
I think we choose the analog games because it's a domain of games that is not very well developed. It's very behind digital games, by example, and card games is just easy to work with rather than tabletop games, since there's more than I think 50 game mechanics for tabletop games and just a little few for card games. And so and you have to translate this to cards games from card games to tabletop games is more easy to start from tabletop games. So it's just a case of domain specification.
Okay. Let's see if you have questions. At the end of your presentation, you are planning to perform experiments with participants for evaluating your approach. Do you intend to perform such experiments after or before you build this GUI tool for professor to create
It's after.
the game?
I think it's more it's better for the professors and the game designers to interact with the web system. So we are just now developing the web system, and the evaluations will happen this month or the next month.
Nice, very nice. We have a question here from Geraldo. As he understands, you write the model of how the game is played in JSON. Do you expect to make online card games?
Yes, online card games it will be in digital sense. So it will be necessary to translate the analog game to digital games. So, and this translation is not yet well defined on the literature of games. So, yeah, there's a lot of games that is card games and is translated to digital card games, but it's not a approach to do this with a scientific way. If you, I could say, but no, I think we just want to keep on analog games, and the web source will be implemented on the web, so it will be available to everyone.
Okay. Okay, congratulations, Rubens, for your works. Thanks a lot
Thank
for the
you.
presentation. And right now, we are finishing our session. Today, we have a nice presentation regarding software engineering and the API, and also how to use it in the games. Maybe it's an important topic for some research and games and so on. And finally, I would like so much for you attending this session, and I would like to wish you a good day and bye. See you soon.